SpaceX's gargantuan Super Heavy Starship, the most powerful rocket ever built, blasted off on its second test flight Saturday, and while the initial stages of the mission went smoothly, the first stage broke apart moments after separation from the Starship upper stage, which then blew itself up as it neared space. Viewed as a successful learning experience by SpaceX, it was the second failure in a row to get the Starship upper stage into space. A frustrating disappointment for Elon Musk's rocket company, and a potentially major setback for NASA, which is counting on the Starship to carry Artemis astronauts to the surface of the moon in the next few years. What exactly went wrong for Ship 25 and Booster 9? And what's next for SpaceX on the Starship program? Let's find out in today's episode of Great SpaceX. Saturday's flight of Starship, a powerful vehicle designed to carry NASA astronauts to the moon, was not a complete success. SpaceX did not achieve the test launch's ultimate objective, a partial trip around the world ending in a splashdown in the Pacific Ocean off the coast of Hawaii. But the test flight, the vehicle's second, did show that the company had fixed key issues that arose during the earlier test operation in April. All 33 engines in the vehicle's lower booster stage fired, and the rocket made it through stage separation when the booster fell away and the 6 engines of the upper stage lit up to carry the vehicle to space. Just beautiful, John Innsbrucker, a SpaceX engineer and live launch commentator, said on the SpaceX webcast. SpaceX's Starship rocket lifted off from Boca Chica, Texas on Saturday on the vehicle's second test flight. By contrast, the first Starship launch badly damaged the launch site, several engines on the booster failed, fires knocked out the steering of the rocket, and the flight termination system took too long to explode. But according to SpaceX's fail fast, learn faster approach toward rocket design, successfully avoiding a repeat of past failures counts as major progress. However, the second flight revealed new challenges that Mr. Musk's engineers must overcome. Soon after stage separation, the booster exploded, otherwise known as a rapid unscheduled disassembly in rocket engineering jargon. The upper stage Starship spacecraft continued heading toward orbit for several more minutes, reaching an altitude of more than 90 miles. But then SpaceX lost contact with it after the flight termination system detonated. In a statement, the Federal Aviation Administration said no injuries or property damage had been reported. It'll conduct a mishap investigation, which is standard anytime something goes wrong with a commercial rocket. The FAA will oversee the SpaceX-led mishap investigation to ensure SpaceX complies with its FAA-approved mishap investigation plan and other regulatory requirements, the agency announced. The FAA only gave SpaceX permission to launch once with its amending launch license, so even if it was successful, the FAA would still need to get involved. Engineers will now have to decipher what went wrong on both the booster and the upper stage spacecraft, make fixes, and then try again. They have fixed issues identified in their first flight and got further than ever before with this type of vehicle, said Phil Larson, who served as a White House space advisor during President Barack Obama's administration and later worked on communication efforts at SpaceX. The magic of engineering is that it is all about learning, iterating the design, and reflying again soon. Daniel L. Dumbacher, the executive director of the American Institute of Aeronautics and Astronautics, agreed. "This is a large launch system," he said. "It's going to take some work to get it to where it needs to go. I have no doubt that the SpaceX team will be able to figure out how to get the launch vehicle working." But hey, why the long face? Do you realize that this can happen much sooner than before? It's all because the Starship pad survived, and that, on top of the first stage performance, is a huge win for SpaceX and NASA. SpaceX's Launchpad appears to be fully intact, indicating that a new water deluge system used to dampen the jarring forces of the Super Heavy rocket's engines during takeoff helped keep the ground facilities safe. Cameron County, the Texas county that encompasses Starship's launch site, opened the single road that runs out to SpaceX's launch facility and the public beaches shortly after launch. It was a quick turnaround for the county, which left the roads closed significantly longer after the inaugural test launch in April. One key factor at play, is that SpaceX acknowledged that the sheer force of Super Heavy's engines after the April launch tore apart the Launchpad. SpaceX's CEO Elon Musk referred to it as a rock tornado. But the new deluge system used during this launch shot nearly 360,000 gallons of water upward as the engines ignited during this morning's launch. When people visited the launch site a few hours after takeoff, the stand that the rocket launched from appeared to be unharmed, and there were no immediately visible signs of large debris in the area. If this were to be true, I honestly wouldn't be surprised if the IFT-3 happens in January or February of next year, with Booster 10 potentially rolling out for static fire testing just a few weeks from now. This will all depend a lot on whether SpaceX decides to repeat the IFT-1/2 mission profile, and of course, if the issues that ended B9 and S25 require major hardware revisions versus minor tweaks and or software changes. Also, based on how successful IFT-2 appeared to be, SpaceX will stay grounded for a while, and none of the obvious candidates, B10, B11, B12, or S26, S28, all the way to S31 and more, will fly next as the company focuses on the next iterations of ship and booster. However, TPS comes to mind as a new problem. IFT-2 puts SpaceX in a position where, if it intends for or needs reuse to be a key part of HLS operations, which is considered one of the most important experimental objectives of the IFT-3, will be ship/booster re-entry/boostback and simulated recovery. And I've got to say, I'm not that confident in this iteration of the heat shield, or even that it's worth flying once re-entry and recovery become the main goals of flight tests. In any case, SpaceX is very good at building rockets, and we should put our trust in them. Musk believes the Super Heavy Starship will open a new era in space transportation. It's by far the largest, most powerful rocket ever built, standing 40 stories tall and tipping the scales at more than 11 million pounds when fully loaded with propellant. Burning methane with liquid oxygen, the rocket is capable of generating a staggering 16.7 million pounds of thrust, more than twice the power of NASA's Space Launch System moon rocket and the legendary Apollo-era Saturn V. The Super Heavy first stage alone stands 230 feet tall, while the Starship upper stage, designed to carry cargo, passengers, or both, towers another 164 feet and is equipped with 6 Raptor engines of its own. It's capable of lifting up to 150 tons of cargo to low Earth orbit. Getting the Super Heavy Starship flying on a regular basis is critical to NASA's Artemis moon program. NASA gave SpaceX a $2.9 billion contract in 2021 to develop a variant of the Starship upper stage to carry astronauts down to the lunar surface in the next 2 to 3 years. In order to send a Starship to the moon, SpaceX must first refuel it in low Earth orbit, robotically, transferring thousands of gallons of super cold cryogenic propellants carried up by multiple Starship tankers. The number of tankers required is not yet known, but senior NASA managers have said more than a dozen will be needed for each Starship sent to the moon. NASA's contract requires one unpiloted lunar test flight before astronauts will make a landing attempt. Artemis managers continue to officially target late 2025 for the first lunar landing with astronauts on board, but that's not remotely feasible given SpaceX's pace in developing the Starship system. It's also not known when SpaceX might be ready to launch paying customers aboard the new rocket. NASA's moon program aside, at least 3 all-civilian missions have been booked to date. Geopolitical urgency has returned to spaceflight, and without SpaceX, NASA would still be renting rides for its astronauts from Russia. NASA Administrator Bill Nelson also frames the Chinese lunar program as a rival to Artemis and one that could reach the lunar surface first. NASA needs SpaceX to succeed to stay competitive in this space race. According to the current schedule, NASA's first Artemis moon landing is to occur in 2025. Delays are expected, including from NASA's own Space Launch System, the rocket that will deliver the astronauts from Florida to lunar orbit, where a Starship vehicle will await them for the touchdown on the moon. Such a prominent placement in NASA's moonshot program gives SpaceX influence in Washington, D.C. and beyond. Well, folks, that's about it for today's episode. Thank you so much for tuning in, and if you'd like to support our channel even further, you can go on ahead and hop on over to our Patreon through that link in the description below. Sign up today and become a patron to gain access to exclusive content. Sounds exciting, right? In any case, we still appreciate your generosity and your passion for space exploration. As always, this is Kevin from Great SpaceX, and until next time, keep looking up.